In this class, we're going to add more variations to our building. We'll start adding cornices to our building. There are many ways to do that. We are going to use what we consider the most efficient one, that is using an overlapping geometry around the whole building with just the cornice for the building. What is an overlapping geometry? As I said in the last class, when you perform actions from different actions from the same input, both actions will perform in the same area, overlapping one to each other, right? Now we're going to make an example of that using an invisible geometry around the building with just the corners. And this is the way to do that. First, we're going to make our cornice. This will be a profile. We will say cornice 1. We're going to make variations of that. Our cornice will have, let's see, 30.3 units, like this. This can be a cornice. Okay. I'm going to label all the segments of trim. And now we're going to put this cornice in my building. I will use an overlapping geometry around this building. First, I have to make an extrude here with an amount of low level H, and my sides will be invisible. Then I will put my the cap. I will make an extrude with fixed profile of my cornice, and this is the result. As you can see here, I have my cornice. I only have to adjust my variable here, slab thickness to 0.3, the same height of the corner. And now I have my corner in the first floor. Now I have to repeat it to the rest of the floors. I will do that using a loop. Okay? We're going to unplug here, and in this cap I'm going to add a loop. My loop will have a repetition of floor number, that is the amount of floors, and I will perform a loop action of an extrude that will have an amount of, we are going to add an expression here of slab thickness plus floor height my sides will be invisible, and then I'm going to transform this into a function. You have to see the lesson of using the loops. This will be my function. Now I connect the looping output and I will perform an overlapping geometry here to put a name on every cap in the loop. See, north. Now I have to select here north and put this to the extrude and also this one. Now I will obtain something went wrong here. Let's see what is it. Okay, I have to define my variables inside this function. This is my variable and the other. And then put the values from the outside to the same variables in the inside. I select my function, configure my variables for that function. I have my two variables and I have to say this in the inside will be the same value of the outside of the variable of the function. Outside I have these values. I have to transfer from the outside of the function to the inside using the same variables. And now I got my cornice in every corner. I have to put in this extrude my caps will be also invisible. Which is the advantage of this method? Well, I can now define other cornices. Let's define another. That can be something like this. This can be another cornice. And then here, I can choose and put one cornice or the other. And then I have my variation. This is the second cornice. It's also the second. Again. Now I have the first one. And that introduces variations in your building. As you can see, we have a very variating building. Sometimes my balcony, sometimes my one cornice, another, and you have to introduce variations in every part of the building. Now I'm going to add some variations in the balconies. I can say I can use something like this. This is this will be one variation. Let's add two more. This will be one. The other variation could be, we rename, is to rail, west to rail, then I will extrude by label. Let's see only this variation. And the sides of this I will extrude. That's an amount of 1.1 units. And my sides, my output, everything will be renamed to wall. Let's see the result of this. Now I have walls on the side. Now I have to rename. In the cap of this, I will rename north to rail and the rest to invisible, and go here, and the result will be this. This cap have to be invisible. Okay. Now I have another kind of balconies that with walls in the sides and rails in the front, or I can do just the contrary for the third choice. I will say rename north to rail, and then I'll say extrude label profile. My sides will be this, and my cap now I will rename is to rail, west to rail, and the rest visible, and goes to this. Let's see the result of this. Now I have a balcony with wall in the front and rails in the sides. That is another variation. Now I put these variations in the choose to the system, choose between them randomly, and then I have more variations in my balconies. This is one. Or no balconies. Nor balconies either. Now I got another kind of balconies. This is the way you can introduce many variations in your buildings. See? Okay. You can add other variations in your windows. For example, I will import another window that can be this one. Okay, and then use here and choose one or two, and here we have another kind of window. You can see this is a different window, and you can choose in the windows also between one or two. You can make the molding around the window or go directly to the window without moldings. These have molding. This doesn't. And that is the way you introduce variations over variations, and the result is that you obtain many different buildings from one. There is something more. If you can add a wall, for example, that bounds with another building, in case you are going to use this building in a large scene, you can make a plain wall to use it at bound with the building on the side. If you select, for example, I will put this wall in my sketch as wall 2, for example. This is a way to do that. Let's see what is the result. I have this, but I still have the cornices. I have to make a variation here. Instead of make an extrusion here, I have to make a rename all edges to cornice 1 and wall 2 to wall 2, and then I make an extrude by label, the same with the second. Add input here, and my caps will be invisible. This will be cornice. And now the result is this. I have to do the same with the cornice, with the crown. Where is my crown? Okay. This is my crown. I have to do the same thing. I have to rename all edges to ground 1 and wall 2 to wall 2, and then make an extraction by label. This is my result. Now I have a building with the plane face for a boundary with the building in its sides. The result of this will be the following. First, we're going to transform the whole building into a function I'm going to use a choose here with only one output to group these two geometries, and then I will transform this whole geometry into a function. That's it. Now I can restore this. Okay. And then I will say here this will be one seat each. And here in my variations I have this DXF already prepared, all labeled, except this I have to label this one too. Okay, all labeled to test this building in a map. I'll say select south and put this building, and let's see the result for that variation. I will render my scene and you will see all the variations of your building. Maybe I have to put some variations on my floor height, on my number of floors. Okay, I have to, in the variables now are in the inside of the function. I have to erase it from the outside. For the variables, make random in the inside of the function. Now, the result will be this. As you can see now, you have variations of the same building for your scene. With different balconies, different windows, different cornices. You can get another scene. You have different variations. And this is the most simple way you may build a model of the building using Threedee. That's it for this class. In the next lesson, we're going to explore some other ways to start and model a building using 3D. Thank you.